Assalamu alaikum wa rahmatullah. Welcome guys. Today we have some notes about writing equivalent expression. But remember that our objective today is to use properties of operations to write equivalent expressions. Okay? First we need to know what does equivalent expressions mean. The word equivalent, it's like equal. But with expressions we are using equivalent because they are not exactly the same. Maybe we have different variables, different symbols, but at last when we substitute for this variable by the same numerical value, we would have the same answer. Let us take an example about equivalent expressions. If we have 2 of 3x, this equivalent with 6x. How could I know? Take x equals 2, for example. At x equals 2, the left hand side here would be 2 times 3 times 2. So it would be 2 times 6, which is 12. For right hand side, it would be 6 times 2, which is 12. So at this case, we can say they are exactly equal. So now we have 3x is equivalent to 6x. Okay? Next, we need to know what are properties of operations that we're gonna use to write equivalent expressions. First property we have commutative property. First one, commutative property. What is commutative property? All of us know that 1 plus 3 equals 4, and the 3 plus 1 equals 4 as well. 2 times 3 equals 6, and the 3 times 2 equals 6. But this doesn't work with division or subtraction. You know 5 minus 2 equals 3, but 2 minus 5, it's negative 3. They are not equal. Also, 5 divided by 1 equals 5. But 1 divided by 5 is 1/5, so they are not equal. So we can say a plus b equals b plus a for any two numbers. Also a times b equals b times a. This commutative property for addition and this commutative property for multiplication. Second property we're gonna use is called associative property. Associative property or associative property. In associative property, if I ask you to add 5 plus 3 plus 4, for me, I will divide this in 2 steps. 5 plus 3 first equals 8, then plus 4 equals 12. Or you can say 5 plus 3 plus 4, 3 plus 4 equals 7, so 5 plus 7 equals 12. This exactly the associative property. So in associative property, if you have to add 3 numbers, you can take 2 of them first, then add the last one, or a plus b plus c. Also, we can make this in multiplication. A times b times c equals a times b all times c, or a times b times c. And this doesn't work with division and subtraction. If you have 12 minus 6 minus 3 equals what? As we know, 12 minus 6 equals 6, minus 3 equals 3. If you make this 12 minus 6 minus 3, you would have the same. 12 minus 6 equals 6, minus 3 equals 3. But if you have 12 minus 6 minus 3, at this case, you have 6 minus 3. As we know, we have to use order of operations. We have a bracket. So 6 minus 3 equals 3. Now 12 minus 3 equals 9. So now they are not equal. Also, if you have 12 divided by 6 divided by 2, 12 divided by 6 equals 2, and 2 divided by 2 equals 1. If you put this 12 divided by 6 divided by 2, so it would be 12 divided by 6 equals 2, divided by 2 equals 1 as well. But 12 divided by 6 divided by 2, so it would be 6 divided 2 equals 3, so 12 divided by 3 equals 4, so they are not equal. So the associative property doesn't work with subtraction and division. Next, we have the most important property, which called distributive property. Distributive property or distributive law. In distributive property, we're gonna distribute the multiplication on addition or subtraction. As we know, some expressions are consists of one term or two terms or three terms and so. If I multiply the expression by a number, it means I have to multiply each term by this number. Okay? A times B plus C equals A here is multiplied by this bracket. So we have to distribute this A on each term inside the bracket. So it would be A times B plus down A times C. So it would be A times B plus A times C. Also, if we have A times B minus C, by the same way, it would be A times B minus down A times C. Okay? Example, if you have 3 times 2 plus 5. As we know, 2 plus 5 equals 7. So 3 times 7 equals 21. Applying this rule, you have to multiply 3 by 2 first, then put plus down, then multiply 3 by 5. So let us apply this according to distributive property. 3, which is A times B times 2 plus 3 times 5. So it's equal. 3 times 2 equals 6 plus 3 times 5 equals 15. So equals 21, the same answer. So we are right. Let us apply this. Don't forget our objective. Our objective to use properties of operations to write equivalent expressions. So now, remember that we have commutative property for addition and multiplication, associative property, and distributive property. We have to distribute the multiplication operation on addition or subtraction. Example, convince me. Write an expression that is equivalent to 3y minus 9. As we know, guys, we have many properties. Let us check. Can we use for this 3y minus 9, can we use commutative property? Of course no, because as we said, commutative property doesn't work with subtraction. So, can we use associative property? Also no, because here we don't have 3 terms, we just have 2 terms. And even if we have 3 terms, here we have subtraction, and also associative property does not work with subtraction. So what shall we do? We have to use distributive property. But here we don't have bracket to multiply with a number. But we're gonna do the inverse way. As we know, if we have A times B minus C, so it would be A times B minus A times C. Here we have this side, so we have to go to this side. How? Here you can notice that 3 and 9, both of them have common factors, which is 3. So we can take 3 as a common factor from this. So we can rewrite this as 3 times y minus 3 times 3. Now this form exactly this one. Here we have 3 as a common factor as A here. So we can rewrite this as 3 and bracket y minus 3. and this equivalent expression to that one. To make sure, let us make it again. 3 times y equals, yes, 3y. Minus down, and the 3 times 3 equals 9, so they are equivalent. So the answer is 3 times y minus 3 in a bracket. Next, use properties of operations to complete the equivalent expressions. Number 3, 2 and bracket r plus 3. Here it's distributive property, as you can see. So we're gonna multiply 2 by each term inside. So multiply 2 by r to get 2r, and plus down 2 times 3 equals 6. So it would be 2r plus 6. Number 4, 6 and bracket 4s minus 1. You have to multiply 6 by each term inside. So multiply 6 by 4s, then multiply 6 by 1. So 6 times 4, 24s minus 6 times 1 equals 6. The last one is the same like the example we just did. Actually, 80 plus 2, we have many answers for this. We can use here the commutative property and write it as 2 plus 80. This is answer. Or you can take common factor, as he wants you to make it here, 2 as common factor. So now divide 80 by 2 equals 40. So the remainder is 4t. And 2 divided by 2 equals 1. And we can make sure, if you multiply again, 2 times 40 equals 80. And 2 times 1 equals 2. So you are right. Okay. So these are the answers like we did. In 6 to 8, use properties of operations to complete the equivalent expressions. At number 6, 3 bracket m plus 3, we have to multiply 3 by each term inside the bracket. So 3 times m equals 3m, and 3 times 3 equals 9. Second, 20n minus 4m. Here, he makes it very easy for us because he showed you the common factor, which is 4. So just you have to divide both terms by 4. So 20n divided by 4 equals 5n. So the answer is 5. And 4 divided 4 equals 1. So it's 1m. And here we have to multiply 4 by both of these. So 4 times 3 equals 12p. And 4 times 2.5 equals 10. Now, in 9 to 16, write equivalent expressions. First one, using distributive property, so it would be 3x minus 18. We just multiplied 3 by both terms inside the bracket. Number 10, we have two answers. First answer is to take the common factor 2, so it would be 2, and here x plus 5. X plus 5. Or you can use the commutative property and write as 10 plus 2x. At number 11, multiply 8 by both of these. So it would be 8 times 2y equals 16y. And 8 times 1 over 4, it means 8 divided by 4, which is 2. Or also you can write this as 8 times 1 over 4 plus 2y, and then you used the commutative property. At number 12, you have 3 terms, associative property, so it would be 5.7 plus 3z plus 0.3. At number 13, take 5 as a common factor using distributive property, so it would be w minus 3. Here at number 13, we cannot make commutative as we have subtraction. At number 14, you can take 2 as a common factor, so you have x plus 2y, or also you can make it 4y plus 2x, and this using commutative property. At number 15, using distributive property, so it would be 10 square y plus 24.5. At number 16, we have associative property of multiplication, so it would be 3.4 times cubic z all times 4. Thanks for watching. All my best wishes for you all.